All right, so we just finished talking a little bit about anions and cations, positive and negative. And this is just a quick little reminder and just moving along. Positive charge, they must have more positives than negative particles. Again, those are protons and electrons. Cation. Negative charge, more negatives than positives, and that's an anion. And again, I do want to show a few more examples. Again, let's say we have sodium with a plus charge. Sodium always has, if I write underneath here, protons, is going to have 11 protons. Why? Because it's sodium. You look up Na on the periodic table, which you'll always have on my wall. Sodium has 11 protons. If it has a positive charge, then that means in order to figure out how many electrons, or to notice that it is a cation, there are 10 electrons. Why? Because 11 pluses, 10 minuses gives you a 1 plus net charge. We write that in the upper right corner. Another example of a cation, Mg with a 2 plus charge. Magnesium, how many protons? Well, there are 12 because that's what magnesium is. With a 2 plus charge, that must mean we have 2 more positives than negatives. So therefore, 10 electrons. 12 pluses, 10 minuses gives you that 2 plus charge. Anions, if I give you a couple examples of anions, if I have Cl with a minus charge, again, if I were to look at protons and electrons, there are 17 protons in chlorine because it's chlorine. Chlorine has 17 protons, always has 17 protons. With a negative charge, we must have more electrons, more minuses than pluses, and so therefore we have that 1 minus charge as we see on chlorine. Another example, if I have nitrogen with a 3 minus charge, protons, well, there would be 7. Because it's nitrogen, there are 7 protons. There would be 10 electrons, again, 7 pluses, 10 minuses, gives you that net charge of 3 minus. So there's your cations. Again, I remind you, cations are our positive ones, anions are our negative ones. So that's a ion, and it's really important to recognize ions because then that starts to get into forming compounds, etc., etc. Okay, moving right along. What do ions, or what do elements form for ions? Sodium's not going to form just some random charged particle. It's not going to form negative charges. You're going to form cations when you have some elements. So what are they? Let's take a look at our periodic table, okay? Sodium's a good example. Sodium, Na, is right here. It's right here on the far left side. Sodium has 11 protons and 11 electrons when it's an atom, right? An atom is a neutral substance, same number of protons and same number of electrons. What ions do they form? Well, all atoms or all elements want to form ions so that they have a stable electron configuration. Okay, and what is a stable electron configuration? Well, it's so that the electrons are in the outermost energy level, and they are stable. So they are specifically charged so that they have a stable electron configuration. All right, so that's really important, the stability, okay? They want to form ions like a noble gas. The noble gases have these stable electron configurations. So for something like sodium, all right, if we look at sodium, it's over here, and we take a look at what it would need to do to have a similar electron configuration as a noble gas. It has 11 electrons. Well, sodium is always going to have 11 protons, which are your positive. It can lose 1 electron and form 10 electrons, which is a 1 plus charge. If it has 10 electrons, take a look at what that is. 10 is neon. Neon has 10 protons and 10 electrons. But if sodium loses 1 electron, it's going to have 10 electrons, which is like neon. It could also, sodium, oops, I should really put this up here, form a 1 plus charge when it loses 1 electron. Sodium could also, still going to have 11 protons, but it could gain 7 electrons. Gain 7 electrons in order to be like argon. So notice the noble gas argon has 18 protons and 18 electrons. And so sodium could gain 7 electrons, which would form a 7 minus charge. Okay? When you think about it, if we think about how elements gain or lose electrons, it's kind of like a cost to the element. Which one do you think costs less? Losing 1 or gaining 7? Absolutely, losing 1 is a much easier cost, and so sodium is going to form that 1 plus charge. It will not want to gain 7 electrons. It just costs it too much. So sodium forms that 1 plus charge and will always form that 1 plus charge. Okay? So again, sodium over here forms that 1 plus charge. All of those elements on that side are going to form a 1 plus charge. Okay? Trying to back up here. Still on a previous. I want to go here. So there you are. So let me go ahead and fill this 1 plus up here. That's what these are going to form. If you look at the next family, magnesium, let's say. Magnesium has 12 protons, 12 electrons. And you can tell very easily that if it loses 2 electrons, it would still have 12 protons, 10 electrons. That is like neon. So losing 2, magnesium would form a 2 plus. It also, 12 protons, 12 electrons, could gain 6 electrons to be like a noble gas, right? It would have 12 protons, 18 electrons, and it would be like argon. We'd have magnesium with a 6 minus charge. If you gain 6, it forms a 6 minus. Again, it's not going to want to do that. It's going to want to form the losing of 2, form that cation. So there's that family. All of the elements in each family are going to want to do the same thing as the ones that I've just given you. Okay? All of these in the middle are going to form positive charges. They're always going to be positive. They can change its charge. Sometimes they're stable with a loss of 1. Sometimes they're stable with a loss of 2 electrons, loss of 3. So we would have a loss of 1, loss of 2, loss of 3. And again, its positive charge means losing electrons. But again, it's always positive. This family, 3 positive. Carbon, usually when I say carbon, that's family, but they can change. Carbon family, usually a 4 plus, but can change. Here we have 3 minus, 2 minus, 1 minus, and then of course our noble gases. Let me see if I can get a light going. So your noble gases. Again, these elements all do it so they can be like a noble gas. And take a look. If this is our noble gas family right here, they're neutral. They don't want to lose or gain electrons. Notice that really we're 1 away, gaining 1. 2 away, gaining 2. 3 away, gaining 3. Same thing here if we look to the left side. if we kind of wrap our periodic table around, then basically this family right here is only 1 away from the noble gases. This is 1, 2 away. If we ignore our middle, this is 1, 2, 3 away. And again, how far away is it from the periodic table, from the noble gases, will show what its charge is likely to be. Okay, I've created a little song for this. I say the elements or the families form these charges. They form, and I'm going to do it as I sing my song here. 1 plus 2 plus, skip the middle, 3 plus 4 plus, but can change, 3 minus 2 minus 1 minus. And of course your noble gases are neutral. So not really much of a song, but at least we go 1 plus 2 plus, skip our middle, 3 plus 4 plus, but can change, 3 minus 2 minus 1 minus. And those are the charges that these elements form.